Hello student, today our topic is integration. Integration can be called by, can be defined by the conception of antiderivative. Why? Because in differentiation, the main job is separating the points from the curve. But see, if I uh, analyze the nomenclature, integration, it means what? Means combining, summation. You have heard the term national integrity, means all communities to be put together. So integration refers that. So integration means summation. So integration is summation. Now summations, first alphabet is S. So integration will be denoted by S. Antiderivative means this is called differential operator, DDX. You are differentiating what? Fx, which we are taught in class 11 and the advanced version in class 12. Now, integration means, see, summation, differentiation. I approach their opposite to each other. So integration is called anti-derivative. Once you bring the term antiderivative, then you can write 1 by ddx. Sorry. Instead of 1 by d, you can write s sign, and you are going to anti-differentiate what? Some function fx, so that fx will be put, and where this dx will go? Differential. The differential will go with fx. So this is the way you can formulate the integrand. Now after integration, you will get family of curve. Say phi x, once you integrate it, then you will get a different function fx, different function phi x with plus c. You can ask me from where this c is inherited. For example, say y is equal to 2x and y is equal to 2x plus 5. See, two linear equation. If I differentiate it, I will get what? 2. But if I differentiate it, I will get what? Then also 2. So, though the two functions were differed by a constant term, but once I differentiated both, I get the same result. Now, by the perception of integration, we have come to know that after differentiation, the value you are getting will be integrated and you will get back the original function. Okay. So if you integrate 2 with respect to x, that will give you 2x. Now the question is, by conception, we would get back the same function after integration. But see, here 2x we are getting, but here two functions, both were generated by 2x but differed by a constant term. So I do not know whether I will put 5 or not. Why? Because 2, its integration is 2x. And that 2x, this 2, its integration is 2x plus 5. Then how can I distinguish? Then I will have to put a constant. What constant? If I put 0, I will get back this thing. If I put 5, I get back this thing. But 2x plus c is called family of curve. Why it is called family? Because if you get put c is equal to 0, that 2x with a linear equation passes to origin. If you put c is equal to 1, that 2x plus 1, it will a straight line passes through some other point. C is equal to 2, other point. So this will be the bunch of parallel lines. So it is called family of curve. So C depicts family of curve. If C is unknown, the this is called primitive. It will become family of curve. Once you put the value of C, then it will be a single curve. Okay, so that is the basics of integration. Now, few formulas you have to learn. These formulas are reverse with the approach of the formulas differentiation. See, I'm showing you. In differentiation, you did what? Say a to the power x with respect to x. What you got? A to the power x by, sorry, log a. A to the power x log a. So, if you are asked to integrate integration of a to the power x, you are asked to find it to the integration of a to the power x. How will you do? See, integration of a to the power x. Integration of a to the power x is a to the power x by log a. So here log a to the base b came with a to the power x, but here same log a to the base e will come in the denominator. Hope you understood? Or you see, if you differentiate this part, how to differentiate? Split into two parts. See, all of you know that constant terms derivative is 0. So that part will be void. And here, this constant term will be brought out. So, cancel. Hope you understood that this result, if I differentiate, I will get a to the power x. And if you integrate a to the power x, you will get back this result. So, you understand now why it is called antiderivative. So that is one of the formula. This formula, important formula. What has to be remembered in this formula? Base constant, power variable. Now what happens if base variables power constant? Example, see Again, again and again, this will recur that integration is antiderivative. So let us take one result in differentiation. What result? That x to the power n plus 1 by n plus 1. If you differentiate it, you will get what? Here n plus 1 is variable. Okay? Got out. What will be left for you? This. Then this formula will be followed by differentiation. So this function's derivative is x to the power n. So by antiderivative concept, x to the power n integration is but there is one limitation in this formula. What is that limitation? Instead of n, if I put minus 1, you see, you will get one undefined result. So, as a side note, you have to append n not equal to minus 1. So, this highlighted part is one of the formula. This is one of the formula. What is the basic difference between this and this formula? Here, base constant, power variable, base variable, power constant. Okay, so must be remembered. Here you see 2 to the, suppose 2 to the power x. Then what formula to be chosen to integrate is constant power variable. Then and then that formula will be will be knocking at you. You will get 2 to the power x log 2. Hope you understood. But once you get x to the power 7, so at the flicker of moment, what formula will knock at you? X to the power 7. Okay. So I'm skipping to the next page. Next part. See, you differentiate cos mx by m. M will be brought out. So differentiation of this is this. Then you can get the integration also. Okay. Therefore, okay, got it? M is what? Real number. In the same manner, then you see differentiation of tan mx. See, tan mx by m. M is constant. Pick out. What is the differentiation of it? So tan mx by m is differentiation once you get sec square mx. Therefore, sec square mx's integration is tan mx by m plus c. In each case, c has to be mentioned. Similarly, sec mx, tan mx. So this formula to be learned. You know, log x's derivative is 1 by x. So these are formula. These are, you know, uh, very nominal level explanation of extracting the formula. You see, log x's differentiation is 1 by x as per our knowledge. Therefore, 1 by x's integration with respect to x is log x. Okay. Now, Ravi, so these are so few simple properties. My suggestion, you make a chart. You make a chart, don't try to mark the formulas. If you mark the formulas, one formula will be overlapped with other. Hardly you can memorize that. And if you are involved in recalling the formulas, then hardly you can involve yourself in solving a problem. So make a formula chart, do as possible number of sums every day, understand? Then in automatic manner, this formula will become part of our DNA. Okay. So this is the key of success. This is the way you can memorize all this formula. There is nothing else, no other trick to bring them in your own feet. Now you see, like like differentiation, here UV form will be there, but the question is that will be in later. That will be introduced in later through bypass. Here you can split to integration like differentiation. U plus minus b dx, that is u dx plus minus b dx. Okay. So these formulas you have to learn. So integration is only formula? No. Now the curve will be provided whose differentiation was done, and we have to then you have to integrate to get back the original function. Okay, wait for a while. Now, what is its practical use in maths? So to do that, we have to take some reference of few sums. Though this is not nominal level formula, integrations is widerness is unfathomable. First of all, first chapter demands the simplicity. Suppose one sum is given, sine to the power 8x minus cos to the power 8x by 1 minus 2 sine square x cos square x. So in this sum at the beginning, no requirement of integration. First, that integrand has to be simplified. So you must have good grip on trigonometrical function and algebra. See, Here you are getting a square minus b square. You are getting the semblance of a square minus b square. How? No disturbance in denominator. Okay. Once you get this, then what formula does it knock you? A square minus b square formula. Okay. Again, now in this part, class 7 level formula is speaking. What? A square plus b square. Inadequate place, so I'm shifting here. A to the power 4 plus b to the power 4, you recall your memory. In class 7 or 6, you used to do this a square plus b square type sum. Sine square x whole square. And here, sine square x whole square by now a square plus b square formula is what? A square plus b square formula. A plus b whole square minus 2ab. Okay, and that part which is a little bit clumsy due to my handwriting. A square minus b square. That is square minus b square term. Sine square x plus cos square x by x. So what would be the next term? Sine square x plus cos square x 1. Sine square x plus cos square x 1. And in class 7, in multiple angle, we are taught cos square theta minus sine square theta is equal to cos 2 theta. But here the it given in reverse form, sine square x minus cos square x, so minus cos 2x. Cancel. Minus cos 2x will be brought out. What is the formula of cos 2x? Few minutes back we did cos mx. Integration sine 2x by 2. Not minus. That was in differentiation. So in this sum, what is the role of integration? Some formal role at the last stage. But throughout the sum, you have got the simplification, a craft, a grip on trigonometrical calculation. So must be careful in finding the grip of trigonometry. Okay, so I'm wrapping this sum, good sum, that is not JE level, but in NCERT miscellaneous question. Okay, in question number 17 or 18, the sum is confined. Now, suppose you have got x to the power n dx, but n cannot be negative. You will be allowed to integrate. Why? Because here the variable with respect to which you are integrate and the variable of integrand are same. X to the power n is being integrated with respect to x. Okay, no problem. You can directly write. But the question is, here state approach base variable power constant. But question is, if you get x plus b whole to the power n dx, then what will you do? Here also variable base is variable power constant, so somehow same formula to be applied here. But the question is, here with respect to which variable we are told to integrate x, but here the base which is variable given in which form x plus b, they are not same. Then from this problem, like chain rule in differentiation, here we are getting substitution. Substitution means this, this what I can say, shifted x-axis will be considered as a new variable. Let means till now you get this result, means you are told to integrate with respect to x. Now you are shifting x to z axis. That means you will be allowed to integrate the function with respect to z, not x. Then what will you do? I will consider this thing as z. Once you consider this thing as z, you need differentiation. Why? Actually, in integration, that is called small differential part. Okay, so that dx has to be converted to dz. Okay, so this x plus b will be differentiated with respect to x. Understand? Now, split into two parts. What will you do with this x? A has no role in the sum. Kick out. A ddx of x. P is a constant term, differentiation 0. ddx of x is 1. Dx is dz by a. So, once I substituted the original axis by z for our convenience, then the differential dx also converted into dz, because the variables, variable of the base and the variable with respect to which you are integrating must be set. So place there z to the power n dz by a. So 1 by a is constant. Got out. You have got the integration in terms of z, but z is assumed value. You have to shift back to original function x plus b. So this is the answer. Here, substitution is required. Hope you understood. Ravi now. So what's the now substitution is one of the most important part of this integration. One big integrand can be simplified by substitution. See, in substitution, if you get this time a cos x plus b sin x by b cos x plus a sin x form, whatever be the value of a and b, that will be immaterial. Okay, so here one property, one formula, or one trick, whatever you say, can be remembered. What is that? The numerator part can be compared to L differentiation of denominator plus M denominator. Okay, so numerator can be replaced by this. Then what is Lm? Lm constant. So you differentiate it, you will get what? Minus b sin x plus a cos x plus this will remain unchanged. Okay. Now you separate the like terms. Like term means in right hand side, all the sin x will be clubbed together and cos x will be clubbed together. Now you compare the like terms. Compare the like terms. Like term means sin x's coefficient will be compared to sin x's coefficient. Cos x's coefficient will be compared to cos x's coefficient. So here sin x's coefficient is b. Once you get these two equations, solve and get Lm. Now, next step should be what? Instead of this numerator, you have to replace this part. Integration of L differentiation of by with respect to x. Now you split into two parts. This into ddx of this into dx by b cos x plus a sin x plus whole dx. We are able to split it into two parts. Here dx and dx will be dropped, and that has become the differential. So you will get L here. This part will get cancelled, only m will be brought out 1 dx. So what conclusion you can draw? Instead of this, you can put log, and that is x plus. So if you get the integration of this type, means linear combination of trigonometry, okay, in numerator and denominator both, then that is the approach. Okay. So one sum of this type, this is, this is in general we have explained. Now once if specific sum is given, then how to define it. Suppose you have got sin x by integration of sin x by sin x minus cos x. How to define that? So here sin x is the numerator, this is the denominator. So sin x is equal to L differentiation of denominator plus m into denominator. Okay, just following the previous rule, we have got it. Sin x's differentiation is cos x. Cos x's differentiation is plus sin x. Open it and separate sin x cos x. Sin x's coefficient, here sin x will be multiplied by L, here sin x will be multiplied by M. Here cos x will be multiplied by L, and here M. Here cos x term is missing. So bring one cos x term, otherwise hardly you can compare the like terms. Here you see cos x, its coefficient is 0, here L minus M. Compare. And here L plus M is 1. Solve it. 2L is equal to 1, L is equal to half. Once you get L is equal to half, M is also half. Hope you all could follow. Now, instead of this sin x, you can write L ddx of sin x minus cos x plus M sin x minus cos x. What I have written this thing against what? Against what? Against sin x by sin x minus cos x. Now split it into two parts. How to split? In the previous, an explanation you got it. This part by this, then this part by this. This part into dx means integration of L ddx by plus cancel. So here this dx and dx will be dropped. Don't cancel. Don't cancel. Drop it. So this part A will be brought out and this has become the differential. And that is M1 base. That is L we got what? Half log sin x minus cos x. N is also half x plus. So that is the answer. So if you know this trick, there will be no scope of doing any mistake. Okay. I'm rubbing now. Now, your properties mode is coming like that. You see integration of sorry, tan x. Tan x sin x by cos x. You let cos x is equal to t. Then minus sin x dx is equal to dt minus dt. So instead of this, you can put minus dt by t. Now, what about this minus brought out? What is t? Cos x. What this minus will go to the power using the log property. Log sec x plus. So don't think that this is a sum. This is the formula actually. One derivation I have shown. Tan x is equal to log sec x plus c. Similarly, cot x Similarly, cot x dx log sin x plus. Okay, so this is one formula, the highlighted part. This is the proof. This is another important property. Integration of sec x log sec x plus tan x plus c, or integration of cosec x log cosec x minus cot x plus. Hope you have understood what is taught. Now, one problem based on these basic formula will do, but the problem is very important. Even this problem came in not directly, but one portion of that sum will be related to the sum which I'm going to show you. Okay, I'm rubbing down. Suppose you have got integration of sin x minus a into x minus a. So once you get this type of expression, always in rough work, find the difference between the angle. Had it been cos instead of sine, the approach would have been same. See the difference, x minus a minus x minus b, b minus a. So you do one thing, you multiply sine b minus a to the numerator, and to balance 1 by sine b minus in the denominator, another part will remain same. Other part will remain same. Now instead of b minus a, what can you write? Such a difference you have got. Here this part is constant, so I have kept that part out of log. You could have told that this part, why not? So this part, to introduce this part, we have to bring this part. So we have introduced, and see, it is still now it seems to us, constant. But see, instead of b minus, if you put this result, you will get the difference of angle, and that that has variable. So sine instead of b minus a, x minus a, x minus. So what formula reminds you? Sin a minus b. Sin a cos b cos a sin b. Now split this by this minus this by this. This by this. Minus. Hope you understood. This part cancel. Here, this part cancel. So what do we stand now? Cos by sine cot minus okay. So we have just got in terms of cot, and cot few minutes back you are taught. What you are taught? Cot means log, log silence. Plus, that is the sum. So main trick stands here. You have to follow. Understand? Okay. Try to. I will send few sums. You will try, and the next part will be taught later. But today it is enough. Hope you understood. Integration is not so tough. Pillar of calculus. Though the pillars, toughness and rigidity will be diluted. So don't worry. Be happy. See you in the next class. Goodbye.